Dear children, welcome to another lesson in grade 9 science, nanotechnology and its application. So, in this lesson we are going to discuss what is nanometer, what are nanomaterials, what are nanoparticles and the applications of nanotechnology and the adverse effect of nanotechnology, and what are the devices that we are going to use to observe the nanoscale materials. So, let us see what is nano. Nano is 1 into 10 to the power minus 9 of a unit. So, 1 nanometer is equal to 1 into 10 to the power minus 9 meters. If you take 1 nanoliter, it is equal to 1 into 10 to the power minus 9 liters. 1 nanogram is equal to 1 into 10 to the power minus 9 gram. So, nano is not visible to our naked eye. So, human eye or our naked eye is sensitive to centimeter or micrometer scale, even we are not sensitive. So, we use microscope. So, therefore, nano is not visible to our naked eye. So, let us see how to observe nanoscale particles. So, nano is small. So, why small is good? It is faster, it is lighter and is stronger and is cheaper and less waste products and use less energy to produce, can get into small spaces, different properties at very small scale. So, if you take when something is very small, it is light in weight, less gravitational attraction towards the earth and it produces less products. So, therefore, there are so many advantages of manufacturing something using nanoscale or nanoscale materials. So, let us see what is nanometer. So, nanometer is 10 to the power minus 9 meter is nanometer. So, nanotechnology is taken as the scale range from 1 nanometer to 100 nanometer. So, that is a very small unit of measurement. Now, you can see macromaterials visible to our naked eye, but micromaterials not visible to our naked eye. So, micromaterials we observe using microscope, but nanomaterials cannot be seen even using simple light microscope you have in the school. So, nanomaterials are observed using nanoscale instruments. Example, now you can see DNA molecule not visible to our naked eye, and if you take water molecule not visible to our naked eye, we can see glass of water, but one water molecule not visible to our naked eye. Therefore, we use nano devices or electron microscope to observe these nanoscale materials. So, how to see things on the nanoscale? You can see with the invention of the scanning electron microscope, we call it SEM 1965, and then 1981 the scanning tunneling microscope, that is STM. So, there were greater development in the nanotechnology with the invention of these microscope after 1980s, and later 1985 atomic force microscope, we call it AFM. So, that this atomic force microscope, that invention won Nobel Prize in 1986 in physics. So, you can see now scanning electron microscope SEM, it is very expensive, and we use electron beam to observe the specimen, and transmission electron microscope, and here you can see the image of atomic force microscope AFM. So, we have only few electron microscope in our country, few universities, and it is very expensive. So, how nanoscale materials differ from macro scale materials? So, one important property, greater surface area to volume ratio, and gravitational force become negligible when something become very small or nanoparticle very small, light in weight, therefore, less attraction towards the earth, and they have random molecular motion, and the random molecular motion or Brownian motion become very dominant. So, you can see in this nanoparticle, if the particle has more surface area, so there are more places for the other molecules to come and interact or to make more molecular interaction. So, we call it molecular bonds. So, you can see surface area to volume ratio of nanoparticle. If you take this first cube, it has surface area to volume ratio 2, and the second cube you can see is smaller than the first cube and surface area to volume ratio 3. And the third cube, the smallest one, you can see surface area to volume ratio 6. So, therefore, when the particle become more and more smaller, surface area to volume ratio increases. That is one of the most important property of nanoparticles. Now, what is nanotechnology? The process carried out using materials in the range of 1 nanometer to 100 nanometers, or else production process implemented through nanoparticles. There are two approaches for this. One is top down approach and the other one is bottom up approach. So, that means you start from the nanoscale. Atoms are nanoscale particles. So, you can make the nanoscale structures starting from the nanoscale, or else you can take from bulk to fragments. So, let us see the history of nanotechnology, historical background. So, first you can see in his father of nanotechnology. So, Richard Feynman, he won the Nobel Prize in 1965 for physics. So, he is the first person who introduced the concept of nanotechnology to the world. So, he gave a speech titled "There's Plenty of Room at the Bottom" in 1959. So, he won the Nobel Prize in 1965. Later, nanotechnology, the term was introduced by Norio Taniguchi, and later Eric Dexter invented molecular nanotechnology concept. So, in 2016, Nobel Prize in Chemistry won by 3 scientists, GNPRA, Sir J. Sodat and Bernard Feringa. So, let us see what are nanoparticles. You can see here gold nanoparticles. So, various colors you can observe because these gold nanoparticles having the particle size below 100 nanometers. So, each particle, when the particle size changes, the color of the gold changes, but if you take gold bulk form, it is yellow. But when the particle decreases in size, the color or the interaction of gold particles with light changes. So, therefore, the color of gold changes with the size of the gold particles. Gold is less reactive metal, but when the particles become small in size, the gold particles chemical reactivity also changes, and it is a very good conductor of electricity. The next part, you can see the nanoscale can be seen in the nature. So, one of the best example, Lotus effect. So, if you take these leaves, self cleaning, lotus leaf, water does not retain, any dust particle won't retain in the lotus leaf. So, we call it hydrophobic surface, nano surface, self cleaning surface. Therefore, we use sometimes instead of lunch seed, we use these leaves for packing food. So, because it is clean. So, the main reason due to the nano surface, because it is nano surface. So, there is fine arrangement of particles of nanoscale. So, therefore, if you take some of the animals, the wings of some insects, they have nanoscale surface feathers. So, therefore, self cleaning. Now, you can see there are 3 images here. The first one you can see water get attracted more towards that surface. So, we call it hydrophilic, water loving surface. And the second image you can see hydrophobic surface, water fearing surface. And the third one you can see super hydrophobic surface, that is nanoscale roughness. So, water does not retain. The last one, super hydrophobic surface. So, we use this natural the hydrophobic surface in paints or in fabric, in textile industry. We are going to discuss about those applications. Now, first application of Lotus effect, you can see self cleaning clothes or self cleaning garments. So, these garments, dust, water or the other particles, germs won't retain because of nanoscale roughness. And second application, nano self cleaning glasses, nano glasses. So, most of the windscreen, side mirrors of vehicles. So, from time to time you have to wash them, you need lot of detergents or the car shampoo. So, it's waste of chemicals and environmental pollution, and you have to waste of time, money. But if you have a self cleaning nano glass, no need to wash frequently, you can say goodbye to car wash. So, let us see the third application of Lotus effect, that is self cleaning paints, vehicle paint. So, these vehicle paints very useful because dust particle or water won't retain on these paints. So, the vehicle paint, self cleaning paint. So, therefore, you do not need to put the vehicle to the car wash, you do not need to wash simply at home. So, you do not need to waste money, you can save time and energy, and it reduces the environmental pollution. Let us watch this video. So, when you pour water to this surface, water does not retain on the surface because it is hydrophobic surface, super hydrophobic surface. So, therefore, dust, dirt or any water based medium won't retain on the pen. Now, you can see the muddy water, even no mud, no water retains on the surface. So, it is self cleaning paint. Now, you can see the comparison between non-coated area and the coated area. So, this non-coated area, you can see it retains, so the water retains, and the other area, so the coated with nano paint, nothing retains. So, therefore, it is self cleaning nano paint. Now, next part we are going to discuss about the chemistry of carbon. So, carbon based nanomaterials. So, carbon is the most widely used element in nanotechnology. So, there are more than 100 elements. So, you have heard about this periodic table. Your periodic table contains more than 100 elements. So, carbon is very important in nanoscience. So, there are so many carbon based nanomaterials. You can see graphene, nanodiamonds, nanofibers, nanocones, fullerene and nanotubes. So, all these are widely used in industries. So, graphene is obtained from this graphite. So, we have a graphite deposit in our country, Bogala graphite deposits. We export large quantity of graphite annually, but this graphene is produced and it is very expensive. If we import graphene, we have to pay more than for the amount we have got for the graphite. So, this graphite, most common pencil rod, graphite is used in electrodes and graphite is used as a solid lubricant. This is the structure of graphite. So, graphite has layered structure. It is two dimensional lattice. Graphite has high boiling point. You can see this one layer, the thickness is 1 atom. So, graphene has hexagonal ring and it is the thinnest material and it is very strong and it is 200 times stronger than the steel. So, therefore, if you take this graphite, each dot represent carbon atom. Between the layers there are weak attractive forces. So, if you take this one layer out, we call it graphene. So, this graphene, if you roll this graphene, you will call it carbon nanotube. If you roll only one layer, we call it single wall carbon nanotube, or we call it SWCNT. So, these carbon nanotubes are widely used in water purification because this is nanoscale diameter. And if you roll several layers of graphene, we call it multi-wall carbon nanotube, MWLNT. And the next one, fullerene. This is also carbon based nanomaterial, is like a football. So, there are around 60 carbon atoms in this fullerene. And the next one, you can see the carbon next application, adsorption process of carbon. Adsorption is different from absorption. So, this is only on the surface. There are nanoscale pores in activated carbon. So, this activated carbon is widely used in water purification, and you can see now these days face masks are very popular. So, most of the face masks contain this activated carbon. It can absorb harmful gases and it can purify air. So, in the ancient time, the people are used to put this charcoal, we call it anguru, to purify water in a well. So, it can absorb unwanted colors and it can absorb the other particles because of high surface area. So, therefore, these nanoscale pores contain high surface area. There are different size pores, micropores and large pores. They can absorb lot of other gaseous molecules. And next one, you can see the activated carbon has high adsorption capacity due to high surface area. So, the main application, water purification and purification of gases. So, let us see the other applications of nanoscience or nanotechnology. So, number 1, water purification by CNT. CNT means carbon nanotube. Let us see the applications of carbon nanotubes. one of the most important application, water purification. So, you can see this nano length diameter, you can see this red and the white balls represent water molecules, and water molecules only can pass through this carbon nanotube, but not the other particles. So, if you pass even muddy water or urine, so the viruses, bacteria retains through this filter. Bacteria or virus, germs cannot be transferred, only water molecules, that means water molecules are smaller than the germs or viruses, bacteria. Therefore, you can put water into this, you can filter water through this carbon nanotubes and you can directly drink. Otherwise, normal filters, after the purification process, we have to boil water to kill germs. But when you filter water using carbon nanotubes, you do not need to boil water, you can directly put muddy water and you can, from the other end you can get very pure water and you can directly drink it. So, what is the benefit? You do not need to burn fuel, no energy cost. When you boil water, you have to burn fuel. So, when burning fuel, it causes environmental pollution, air pollution, but here no environmental pollution, no fuel cost, no energy cost, you can directly get this very pure water. So, the next application, nanotechnology in textile industry. So, basically the clothes that we wear. So, let us watch this video how this textile or the clothes act as super hydrophobic surface. Let us watch the video. Now, you can see this coated side water does not retain, but non-coated area water retains, water gets soaked. So, therefore, non-coated area water retains, coated area you can check this and remove water. So, water will not penetrate because of nanoscale roughness in the coated area, but non-coated area, so water retains, so water gets soaked into this fabric. So, therefore, it is a self-cleaning textile. So, let us see various properties of this nano garments or nano textile. You can see water repellence, optical displays, so it can emit various colors due to the different particle size. So, sensors and antibacterial, odor control and UV blocking, strength enhancement and wrinkle resistance. So, basically you do not need to iron clothes, so it is wrinkle resistant, anti-static properties. So, therefore, these clothes is very durable and you can use long, they are long lasting, frequently you do not need to wash them. So, you do not need, you can say goodbye to your washing machine and you do not need to use detergents, you do not need to use any other the shampoo or any other cosmetics for this. So, therefore, you can save basically energy, time and money. So, next you can see the nano glass in transport and consumer goods. You can see auto cleaning glass. So, you can see windscreen wipers we have to frequently change and its additional cost. So, these nano glasses, nano windscreen, so self cleaning, water does not retain. Therefore, even under heavy rain you can drive the vehicle without any barrier. And eye spectacles, television screen and windows and the glasses of windows and the doors also frequently we have to waste time for cleaning these glasses, because traditional glasses there are so many spaces, room to retain dust and germs, but nano glass no room to retain any dust or any germs, even water. Therefore, self cleaning glasses. And you can see that in transport again nano tires. So, these nano tires long lasting, high durability and resistant to wear and tear, and again you can see there are several layers. Graphene is again used in the production of nano tires. Next one, car body panel. Now, in this car body panel you can have self charging batteries or nano batteries. So, when you park the vehicle under strong sunlight, the vehicle get charged. So, self driven vehicle, self charging vehicle. So, now electric vehicles separately you have to charge. So, imagine a person is driving the vehicle to the office in the morning and park the vehicle under strong sunlight throughout the day. So, at the end of the day the vehicle get completely charged. So, no electricity bill, no energy cost. So, therefore, the entire body contain nano solar panels. So, it is very light in weight. So, if the body is made of nanomaterials, we discussed earlier, nanomaterials are very light in weight. So, therefore, vehicle body, the vehicle you can reduce the weight of the vehicle. So, when the weight of the vehicle is reduced, fuel consumption is reduced. So, that driving range increase. So, therefore, you can reduce the weight of the vehicle, as well as you can have self charging panels for the vehicle. So, therefore, it is very useful. In the future you will get these type of vehicles, and again you can see flexible solar panels, and they are very light in weight and they are durable. Therefore, you can have even various instruments, machines, self charging. So, you do not need to put frequently, you do not need to put batteries, because they are self charging. If you use batteries, the batteries contain chemicals. So, it causes environmental pollution. Therefore, these solar cells or solar panels made of nanomaterial, they are very thin and light in weight, and it can reduce the energy cost, and it is very useful for power generation. Next application, fuel cell. So, now currently what we use, electric vehicle and hybrid vehicle. So, next generation vehicles run on fuel cell. So, what is the fuel for these fuel cells? Hydrogen gas and oxygen. So, the fuel cell generate electricity using hydrogen and oxygen. So, this membrane is nanoscale material. So, therefore, in the fuel cell, energy is produced or electricity is produced using hydrogen and oxygen, and nanotechnology is used to generate electricity. So, traditional batteries contain chemicals, acids and various heavy metals. They are harmful to the environment, and they retain in the environment for a longer period, and they are bioaccumulating substances. But these fuel cells, you can get hydrogen gas and oxygen gas from water. So, therefore, in the future the petrol shed become water shed, and petrol tank or the fuel tank become water tank. So, therefore, you can pump water, and water is broken down into oxygen and hydrogen gas, and this oxygen and hydrogen gas used as fuel to generate electricity using this fuel cell. Therefore, next generation vehicles we call them FC vehicle, fuel cell vehicle. Vehicles run on fuel cell. Therefore, they introduce this nanotechnology to generate power in fuel cells. So, therefore, it is very useful in transport. Next application, field of medicine. So, you can see here cancer treatment. So, currently what we use, radiation therapy or chemical treatment for the cancers, but in the future you can get treatment without damaging tissues. So, when we use radiation therapy or chemical therapy for the cancers, not only the cancerous cells, even the normal cells, healthy cells can get damaged due to these radiations, harmful radiations. Therefore, these cancer cells can be destroyed using nanorobots. So, therefore, no damage to the other tissues. So, therefore, in the medicine, cancer can be treated by nanorobots. Next one, you can say goodbye to painful injections in the future. So, you will get nano needle. So, you can see these nanorobots, you can give a vaccine to a person without giving any pain, plus these nanorobots act as the vaccine. So, therefore, it will be very useful nano scale needle in injection syringe. Next one, you can see removal of lipid deposits in blood vessels. So, currently lot of people die due to the heart attack and due to high blood cholesterol. So, these arteries can get blocked due to the deposition of cholesterol. So, now we have to go for, currently what we use, we go for the bypass surgery, or we put a stent to expand these blood capillaries or blood vessels. Now, in the future using this nano robot, you can clean this fat deposited or the lipid deposits inside the arteries and blood vessels. So, therefore, you can reduce the death rate due to the heart attack in the world. Traditionally now what we do for the removal of bladder stones or cholesterol deposits inside the blood vessels, the patients has to undergo surgery. So, after the surgery the patient has to bed rest and until the wounds get healed, and the patient has to get medicines, and so there are side effects of those medicines, but when removing these deposits, either the kidney stones or the bladder stones or the inside the blood vessels, the cholesterol, the lipid deposits. So, you can use nano robots and nano machines to remove those deposits or the bladder stones. So, then no need to do any bed rest and no need to take a lot of medical treatment. So, therefore, less side effects. So, chemotherapy or radiation therapy, normal cells can get damaged, there are a lot of side effects, any medicine has side effects. So, therefore, not only the damaged cells or the cancerous cells, the other cells also can get damaged due to those medicines. And these medicines now after the treatment process, sometimes frequently you have to get these medicines. But this using nanotechnology, if you treat the patients, cancer patients or heart patients or the other complications in organs, so it is very convenient and it is very useful for both patients as well as doctors and the hospitals. So, it can reduce the time and it can reduce the amount of the medicines taken. So, let us watch this video how nanorobots clean these deposits and the bladder stones. Let us watch the video. So, in this video you can see this using nanotechnology, using nano machines, you can clean the block blood vessels or the arteries. So, you can remove those deposits without doing any surgery. So, surgery it is very risky for the patients. Some patients cannot undergo the surgery due to age, due to high blood pressure, due to other complications. So, therefore, no need to any medical treatment. So, you can simply remove these plaques. So, less disturbance from the other complications. So, you can see now even in the gallbladder or urinary bladder, you can crush those bladder stones using these nano machines or nanorobots. So, the patients frequently undergo the surgeries to remove these hard plaque or the stones which can block the path of the urinary tract. So, you can easily remove using these machines. So, this is very useful in medical field in the future for the treatment of not only cancers, but cholesterol deposit or the lipid deposits as well as various stones in the urinary bladder and even in the gallbladder. These nano sensors can be used to visualize the signals reaching from these the treatment area. Even the patients can see how it is done. Even some cancer cells can be removed using those machines. So, the tumors can be removed without undergoing any chemotherapy or undergoing radiation therapy. So, when you use reagents, chemicals, so clinical waste get collected in the environment. So, those clinical waste also can pollute the environment, various medicines and the injection syringe. So, they can cause environmental pollution due to clinical waste, but we can reduce that environmental pollution using this technology. Next one, application in electronic science. So, in electronics we use various electronic components, transistors, diodes, especially mobile phones or computers or laptops. We use lot of electronic devices like transistors, integrated circuit, or we call it ICs. Now, currently we use bulk material to make these transistors, but in the future nano transistors become very small. You can reduce the size of these devices, even the storage can be increased. Example, mobile phone covers, memory chip. So, after every 2 years number of transistors in ICs become double. Therefore, you can store more data and it will be very fast and durable. So, let us see the adverse effects of nanotechnology. Now, adverse like any other technology, in nanotechnology also there are some disadvantages. Example, nano pollution. So, nano pollution means nanoscale material released to the environment can pollute air, can pollute water, and even they can enter even to our body and can cause various complications or diseases. Therefore, we have to be very careful when we use nanoscale material or nano products. So, these nano pollutants can pollute water, air, and even they can enter to our body and cause health problems. Therefore, we have to find the solution also using nanotechnology. So, for this adverse effect, the solution also we have to get from nanotechnology. So, you can have nanofilters to filter the nanoparticles in air. Example, using a nanofilter you can filter harmful nanomaterials, and you can have nanosensors. Nanosensors can be used to check the pollution level, because nanoparticles not visible to our naked eye. So, therefore, we cannot, by observing through our naked eye we can't see this pollution. Therefore, you should need nanosensors, and you can have nanofilters. And next one, you can see they can have biological weapons, chemical weapons or armaments of nanoscale. Therefore, they can use these things in war situation that will be very harmful. So, therefore, in the future there are some adverse effects also in this nanotechnology. So, nano armor military work, they can use these things. So, this imaginary one I have given here, in the future they will use this. Next one. So, we can see the precautionary measures taken, these nanofilters and the nanoscale pollutants in effluent smoke can be filtered using those. So, let us see how to minimize the ill effects of nanotechnology, or what are the precautionary measures that can be taken to minimize the side effects or the ill effects of nanotechnology. So, one solution, you can clean air with nanotechnology. Now, gradually annually the air get polluted due to human activities. So, you can clean air using these nano robots or nano machines, and you can use even nano filters. We can use nano sensors to get images of the polluted area or the industrial smoke, industrial effluents, vehicle smoke. The polluted air can be purified as well as can be detected using these nano sensors. In addition to that, you can clean water using polluted water by nanoparticles, you can clean using these nanofilters. So, dear children, let us summarize today's lesson. So, we started with nano and nanoparticles, then we discuss nanomaterials and how nanomaterials are useful. Then we discuss the devices that are used to observe the nanomaterials, scan in electron microscope, tunnel in microscope, atomic force microscope, and then we discuss carbon based nanomaterials, and then we discuss surface area to volume ratio of the nanoparticles and special properties of the nanomaterials. Then we discuss applications of nanomaterials plus natural phenomena due to this Lotus effect, and applications of Lotus effect in technology. And then we discuss various fields where the nanotechnology is used. Example, medical field, textile industry, then you can transport, medical field, and then there are some ill effects of nanotechnology and what are the precautions that can be taken to minimize those ill effects. So, finally, you can get more informations about this nanotechnology and related applications. So, we have in Sri Lanka there is a separate institute, that is SLINTech, Sri Lankan Institute of Nanotechnology. So, it is Pitipana Homagama. You can get more informations, you can search in the internet and get more informations, the other applications of nanoscience, nanochemistry as well as nanotechnology related industrial products. Okay children, we are going to close the today's lesson with this. So, you can watch this again, channel NIE YouTube. Have a